Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from Chapter 4, Moving Charges and Magnetism. Let's move to question number 1. Two toroids 1 and 2 have total number of turns 200 and 100 with average radii 40 cm and 20 cm. If they carry same current I, the ratio of the magnetic field along the two loop is dash. Formula is B equal to mu naught Ni by 2 pi R. And here N1 and R1 are only changing. That is number of turns and radius only changing. So B1 is proportional to N1 by R1. That is B1 is proportional to N1 by R1 and B2 is proportional to N2 by R2. Then you want to find B1 by B2. B1 by B2 equal to, what's the formula? N1 by R1 into N2 by R2. N2 by R2. And N1 and N2 is given how much? N1 is given 200 and N2 is 100. 200 and 100. And R1 and R2 40 and 20. 40 into 10 power minus 2 and 20 into 10 power minus 2 getting cancelled. Just we will write as it is. Okay, 40 into 20. And cancel this. These two 0 cancel. And this 1 0 cancel. 2, 2, 4, 2, 2 cancel. So what's the answer? Answer is 1. That is 1 by 1. That is 1 is to 1. That is option A. Option A is the correct answer. Let's move to question number 2. A cylindrical conductor of radius capital R is carrying a constant current. The plot of magnitude of magnetic field B with the distance D from the center of the conductor is correctly represented as by the figure dash. Actually, cylindrical conductor of radius R, then B value, that is up to R, B is proportional to R. That is up to radius R, B is directly proportional to the distance R. Or D, as per this D is given, and after R, beyond R, here R is the radius, B is inversely proportional to D, the D is the distance. So which option? Option B is the correct answer. Okay, up to this B is proportional to R, and after R, that's the B is inversely proportional to the distance. Okay, next let's move to question number 3. A long wire carrying a steady current is bent into a circular loop of 1 turn. The magnetic field at the center of the loop is B. It is then bent into a circular coil of N turns. The magnetic field at the center of the coil of N turns will be dash. Formula is B equal to mu naught Ni by 2R. In first condition, that is B equal to 1 loop. So B equal to 1 loop is just N equal to 1 by 2R. And L length is bent to 1 loop. It means 2 pi R equal to L. Then R equal to L by 2 pi. Substitute this here. Then mu naught by 2 into L and I is there as it is into 2 pi. This is your B. Next, for B dash. For B dash, what's the formula? Mu naught N I by 2 R dash. Okay. And for this, 2 pi R dash equal to N into 2 pi R dash equal to L. Then R dash equal to, what's the formula? L by N into 2 pi. Substitute this here. Then your B dash equal to mu naught N I by 2 R dash is 2 into L into N into 2 pi. Then reduce B dash equal to mu naught N square and then I into 2 pi divided by 2L. And you want to find B dash by B. B dash by B. B dash by B. Then you will get N square and all the things will be getting cancelled. So B dash equal to N square. Then B dash by B equal to N square. B dash equal to N square B. That is option B. Option B is the correct answer. Let's move to question number 4. Two similar coils of radius capital R are lying concentrically with their planes at right angles to each other. The currents flowing in them are I and 2I. Then the resultant magnetic field induction at the center will be. Resultant magnetic field formula B R equal to square root of B1 square plus B2 square. That's the formula. And B value B equal to mu naught I by 2R. Then B1 equal to 1 current, that is a 1I, that is a mu naught I by 2R. And B2 equal to 2 mu naught. 2 mu naught I, because 2I that I am taking as 2 mu naught I by 2R. Okay, this is your B2. Then substitute this here, and substituting this here you will get square root of 1 square plus 2 square, right? That is 1 plus 2 square into mu naught I by I by 2r. 2 square is 4, 4 plus 1, 5. Root 5 mu naught I by 2r. That is option A. Option A is the correct answer. Capital R we used, so change it as capital R. Here also capital R, capital R. Okay. Next, let's move to question number 5. A straight wire of diameter 0.5 millimeter carrying a current of 1 ampere is replaced by another wire of 1 millimeter diameter carrying same current. Strength of magnetic field far away is dash. Formula is B equal to mu naught I by 2 pi d. What is d? D is the distance of the point from the wire. And if thickness of the wire is replaced, then it does not change the value. B depends upon only distance 1 by d only, and B is independent of the diameter or radius of the wire. Therefore, its value is same as the earlier value. Let's move to 6th question. A particle of mass m, charge q, and kinetic energy T enters a transverse uniform magnetic field of induction D. After 3 seconds, the kinetic energy of the particle will be dash. That is, magnetic field does not change the kinetic energy. Okay, there is no change. If there is an increase in magnetic field or applying magnetic field, does not change the kinetic energy of the particle. So, there is no change. So same T. Energy will never change. No change is a constant. Maintain constant as T. Okay, let's move to last question. A beam of electrons is moving with constant velocity in a region having simultaneous perpendicular electric and magnetic fields of strength 20 volt per meter and 0.5 Tesla at right angle to the direction of motion of electron. Then the velocity of electron must be dash. Formula: force due to electric field equal to force due to magnetic field equal to force due to magnetic field. Force due to electric field is here Q into E. Force due to magnetic field Q into V cross B. Okay. Q getting cancelled, then V equal to E by B. That is this formula. V equal to E by B. Then substitute. Value of E is 20. 20 divided by B is 0.5. 0.5. 20 by 5 is 4. 20 by 0.5 is 40. 40 meter per second. That is option C. Option C is the correct answer. Thank you, students. In next session, we will see through another chapter in problem solving session.